Again, hey everybody. We're going to go ahead and get started. This is our monthly wastewater scan partner meeting. So hopefully you are in the right place. It's good to see everybody here today. First, I want to say happy National Public Health Week from our cute virus people. We just want to acknowledge and recognize everything that all of you do for public health, including all of our utility members on this call who are playing a really important part in public health by participating in this program and doing this wastewater monitoring work. So happy National Public Health Week. I hope you know that we all appreciate you all very much. And we want to share a lot more information with you today about what's been going on with WastewaterSCAN. So as you know, WastewaterSCAN is a national effort based at Stanford to build a national network for monitoring diseases through municipal wastewater systems. So my name's Marlene. I'm at Emory University, and Allie is at Stanford. She's here on the call. We also have our scaling partners, Verily and National League of Cities, who we work with to power this program and make all of this happen. And then most importantly, and the reason for this call, is all of you, our partners in public works and wastewater and state and local public health, again, who are kind of the reason for everything that we're doing here. So thank you for being a part of this network. Quick overview of where we're at with the program. So we currently have 147 plants that are sampling across the country in 40 states. And overall, the people who are covered by this program represent almost 12% of the US population. So we have a really great slice of representation to be able to look at kind of the patterns for many different infectious disease targets in wastewater across the country. This is what we're currently monitoring. So we have our seasonal and emerging respiratory pathogens, SARS-CoV-2, bunch of influenza targets, influenza A and B, and then subtypes H1, H3, and H5. RSV, human metapneumovirus, and enterovirus D68. This hasn't changed. We have our important enteric pathogens. Right now, that's norovirus G2, also hasn't changed. And emerging and outbreak pathogens of concern, Candida auris, hepatitis A, Mpox clade 1B, and Mpox clade 2. So none of this has changed since our last call, but we want to make sure that you're always updated because things do sometimes change with the program. So we want you to know what we're currently measuring. We also do sequencing of SARS-CoV-2 from about 30 of the sites. And then we have our controls that we run to make sure that all of our results are high quality and that we can clearly interpret them. All of our protocols and publications, you'll receive this slide in your email, so you don't need to get the QR codes quickly right now. We have all of our protocols that are available, and then also kind of the peer-reviewed publications. These are the ones that are kind of we would say the critical background that justifies how we've scaled them, but there are a lot more papers that kind of describe the results and the approach for all of the measurements that we're doing, but these are kind of the critical ones that are the kind of first foundation in our work for a lot of the scaling that we've done. So you can always look at those as well. We have all of our papers and this is all publicly available. So we have, sorry, there's just like a bunch of things popping up on my screen. These papers and fact sheets. So we have submitted papers that are available as preprints. So there is this new preprint on West Nile virus, a preprint on antibiotic resistance across the United States, and we're going to hold a session specifically to talk through that one. And then preprint for Mpox clade 1B nucleic acids in wastewater. So a bunch of different topics that are represented in these preprints that are available. The papers have been submitted and are under review. And then you can see the full published body of work at this link. And I think Amanda is putting these links in the chat. Yep, there we go. And so you can see kind of the narrative overview of a lot of the work that we have and click through to the full papers if you want to read the whole scientific article. Okay, so we also just wanted to do a quick check-in. Like we said, it's National Public Health Week. We are so grateful for all of our partnerships with all of you and everything that you're doing right now. We know that the current situation and your needs have been changing. A lot of things have been changing lately. And so if your work with wastewater monitoring has been impacted by recent federal actions, we wanted to create some space to hear from you about that because, of course, we are all connected in this wastewater world. And so we want to make sure we understand what's going on with you and what your needs are. So if you're comfortable, please take a minute to share in the chat if there has been an impact and if there is, what that is. You can also email us at this email address because we'd love to hear from you and learn more about what's happening. We'll also give a few minutes. We have our Q&A time at the end of our session today, so we're happy to spend a few minutes just having some conversation around this topic. As you know, WastewaterSCAN is not federally funded, but we work so closely with all of you. We want to make sure that we understand what your current situation and needs are. So as you feel comfortable, please, share in the chat, or we'll also give a little bit of time at the end of the meeting after we get through the rest of the material that we have today. And with that, I'm going to pass it over to Allie.
Hi, everybody. So I'm going to cover some of the H5 detection and research that's happening. So next slide. Just to update you all, we're still measuring the H5 marker in wastewater. And this slide summarizes the results to date. So we've had 988 positive detections out of over 2,000 samples analyzed and detected it at least once at 78 sites across 26 states. So if the site is red in the map, it means that the marker has been detected at least once. And then if the state is gray, a darker gray, it means it was detected in a plant in that state. And we've had most recently detections in California, Minnesota, Maryland, Michigan, and New Jersey. So you can look at these data on the website as you like. Next slide. So we thought this would be interesting. Amanda made this really cool time series video, which we'll show twice, that shows how detections changed over time across the United States since we started monitoring about a year ago. And we'll play it one more time, but it's interesting to see, I think, how initially we had a lot of detections in Kansas. I'm sorry, not Kansas, in the Midwest. And then, we had a lot of detections over the winter. A lot was in California. And then we started to have detections in other locations. So, we haven't analyzed this quantitatively to show any kind of spatial pattern, but it's just a different way of visualizing the data. And so that will be available for you to watch if you like to watch movies of H5 instead of movies on Netflix, like The Residents, which I think is the newest trendy thing to watch on Netflix. Okay, next slide. Go to the next slide when possible. Yes. So remember that we do have this fact sheet for translational support if you would like to help interpreting the H5 measurements if you have a positive detection. Next slide. We want to follow up on the email and changes for the H3 assay. So next slide. You all received an email that we discovered that one of the H3 assay primers may not bind correctly to recent sequences of H3 type influenza A viruses based on sequences deposited to Gizzade and NCBI. And so we changed the primer and implemented the new assay on the 14th of March. And that's the new sequence of the assays. Sorry, the primers and probes. Sorry about my cough. So next slide. You'll remember that this slide from last time we had a meeting where we showed the ratio of H1, H3, and H5 over the M gene. For all the data that we had collected from the last influenza season. And so remember that the M gene is present in every strain of influenza A, and H1 and H3 and H5 are only present in the strain subtypes that have the certain versions of the HA gene. So if everything followed the laws of physics, which biology doesn't, by the way, then we would have a sum equal to 1 if we measured H1, H3, and H5. over the M gene. If we summed up all those ratios, it would equal 1. And so these box and whisker plots show across all the sites and all the time until mid-March what that ratio of H1 over M, H3 over M, and H5 over M and their sum were. And so you can see that about half the M gene was H1. We had very little detection of H3 and H5. And so it looked like we were only capturing about 0.5 of the influenza circulating with the H1 marker. And if we compared that data to what was recorded clinically at CDC, the important thing to note is that in CDC's compilation of information from from clinics and hospitals that submit data to them, this past influenza season, about half the cases were H1N1 and half were H3N2. So looking at our data, it just doesn't agree with that. We would have expected more H3. And this is what motivated us to look and see what was going on. And sure enough, we found that our H3 assay seems like it wasn't working correctly. Next slide. So these are data collected to date from mid-March when we changed the H3 assay. So it's the same sort of plot, and you can see that the H3 is we're actually detecting it now. And so it seems like it's working better. And our sum is still not at 1, which isn't surprising because we might have differences in sensitivity between the different assays, but we are now detecting H3 in a way that we expect we should, and our in silico and in vitro testing suggests that this new assay should be working appropriately. So that is a change. And then I updated the little screenshot from the CDC website, again showing that integrated over the entire influenza season, and as well as in week 13 of MMWR week, that we should expect based on clinical samples, half the people have H3N2 and half have H1N1. Now, I don't want to belabor this point, but we do know that the type of people who actually go in and get tested for influenza and have the subtype determined are usually people who are severely ill. So it could be that in reality, if we had the ability to look at infections across all individuals, including those that are asymptomatic or mildly symptomatic, there might be a lot more H1N1 infections. And it just so happens that given how many of those are severe, that it looks like there's an equal amount of H3N2 and H1N1, and we just don't know what the true distribution of infections are. But nevertheless, that looking at this clinical data was helpful for us in sort of realizing that there was an issue with the H3 assay. Next slide. So just to show you about the differences between the two assays. So we have the old, quote, old assay and the new assay. So we took archived RNA from about 80 samples and we ran the new assay on those archived RNA, and we compared it to the old assay and we plotted them here. So if they agreed, they would all fall on the 1-to-1 line, which they don't. And you can see that the new H3, we're getting detections, all the way up along the axis here, where the old assay had very low levels. So basically just confirms that the old assay was giving results that were very, very low or non-detect, whereas the new assay is giving higher results. For example, of the 80 samples, 10 of those were non-detect by both assays. Probably those were samples, we took samples from across the influenza season. So those were probably samples from last October before it was influenza season. And then 35 of those 80 were detected by both assays. And in that case, for samples that both were detected by both assays, they were well correlated. So the R value was 0.9, but they weren't on the 1-to-1 line, they were correlated, but there's a constant that's missing from that. So the old assay was still quite low compared to the new. And then the rest of the samples of the 80 were non-detect by the old assay and detected by the new. Next slide. So just some additional notes. So moving forward, Alessandro, who is on this call, postdoc in my research group, is going to, on the first of each month, he's going to pull all the new sequences from GIZ8 and NCBI and check if there's been any mutations or reassortments that would make our assays not work correctly. And so that is going to be, that's a new QA QC step that we're adding. We have removed all the old H3 data from the API and the website. We still have it in storage, but it's not available because it's just not correct. We are not planning to rerun samples that were run with the old assay. We might choose to rerun some for specific research projects, perhaps, but it's not something we're planning to do across the board. And just a note that influenza A will continue to be tricky because of its tendency to mutate and reassort. And that is what makes it have pandemic potential, is because it can mutate and reassort. That is just the nature of influenza. And so it will continue to be tricky. And as you probably remember, we have encountered various issues with the H assays over time. And this particular gene, the HA gene, is one that mutates very quickly and often because it is part of the it's a protein that's expressed on the outside of the virus, and it is related to its potential to infect cells and also for cells to develop immunity. So it is a smart way for influenza to continue to exist as the nasty virus that it is. Okay, next slide. So just a couple notes about ongoing research that we're doing. We want to keep you guys up to date on research projects that we're doing. So we have been working on Bordetella pertussis, which causes whooping cough. We've been working on that for a while. We also have been working with a few different partners, some maybe on this call, on a measles pilot study. We're using an assay that detects the vaccine strain as well as circulating strains. Uh, we have heard from a number of people at different public health agencies, both local public health and at the federal level, of an interest in potentially scaling this assay across WastewaterSCAN, given the current outbreak. We're not ready to do that yet. We're doing some additional work with other assays and continuing to work with our partners on these pilot studies, and we will share more information with you as time goes on. There is an interest in, of course, detecting measles that's not the vaccine strain, but given the similarities of the genomes, it is very, very tricky to develop an assay to do that. And even assays that exist that claim to do that might have some cross-reactivity. So we're just working with several different assays right now to see what we can do there. We also have been working for a while now on metagenomic methods for sequencing viruses and working on method development for that. And that's something that if we can get working well, we're interested in scaling across some subset of the sites in WastewaterSCAN, just to see how useful you all find that data. And if, I think someday it could be something that could replace digital PCR. We're definitely not there yet, but it's something we're interested in continuing to look at and learn from you whether that sort of data is useful for public health action. We've also been working on Mycobacterium tuberculosis and are working on a pilot study related to that. And then the last 3 bullet points here are basically completed projects. So one is on the antimicrobial resistance genes. That was a cross-sectional study across the US. And we're having a special research overview meeting next Friday on Zoom, which will be recorded, to present on those results to those of you who can attend. And also you'll be able to watch the video later. And Amanda will be sending out emails, and I think has sent out some emails already about that, and we'll continue to send that information so you have it. And then the 2 papers below are submitted as preprints, so we probably could remove them from here, but one is the parvovirus and then the West Nile virus. And we'll talk about the West Nile virus results on a future stakeholder call, maybe next month. Next slide. Okay, so now I'm going to pass it to Amanda, who will spend a short amount of time going over some of the
Okay,
recent
thanks.
results.
Thanks, Allie. So I'm going to go over the categories briefly. I just put a link in the chat to the methodology if you want to check it out. But as a reminder, we categorize wastewater based on trends, whether levels are going up, down, or not changing levels. How are the concentrations now compared to the last 365 days, and the frequency of detection. Next slide. So we have the three archetypes. We have pathogens that are commonly detected, seasonal pathogens, and pathogens that are not commonly detected. As a reminder, we will send out these slides afterwards so you can have a more detailed view of this. And then you can always refer to our methodology in which pathogens are assigned to each category based on the link that I just sent in the chat. Next slide. Okay, so I'm going to go over current categories. So here on the left, we have all the pathogens we are monitoring. So SARS-CoV-2 is in the medium category due to medium concentrations and no trends. I'm going to go into this in a couple of slides, so I'm just going to breeze through this so we have some time for questions at the end. Influenza A is in the high category still, so it's in seasonal onset and in the high category due to high concentrations. Over the last 21 days, it's had a 77% detection rate. But despite that, we're still down. The median concentration is down 55% since 1 month ago. So if you look at the plot on the right, you can see we've had this steep decline in concentration since the beginning of 2025. Influenza B is now in seasonal onset. This happened last week, I believe, or the week before. So we've hit that threshold for, greater than 50% of sites have had consistent detections of influenza B. I'm going to go over this a little bit more in a couple of slides. RSV currently is still in the high category, still in seasonal onset, and that is due to high concentrations, but no trend in the last 21 days. RSV is still being detected in 70% of samples over the last 21 days, but the median concentration over the last 21 days is down 43% compared to the median concentration 1 month ago. Human metapneumovirus, although concentrations are slowly increasing, we have not hit the threshold for seasonal onset, so we are in the low category. EVD 68 is in the low category as it is no longer in seasonal onset across the WastewaterSCAN network, but we still do have 10 sites that are in seasonal onset, and all of those sites are in the greater San Francisco Bay Area and in the Central Valley in California. Neurovirus is still in the high category. We've been in the high category for quite some time, and we are still seeing very high concentrations. The bottom plot on the right, you can see, although we've come down since the beginning of the year, we're still seeing very high concentrations. Mpox clade 1B, low category due to all non-detects. Mpox clade 2 is in the low category as well. We've only had 2 positive detections in the last 21 days. C. auris, we have a 5.8% detection rate, so we're still in that low category. Hepatitis A as well is also in low due to few positive detections. Next slide. So here I wanted to put together kind of a summary plot of the last 2 years of the national aggregate for the respiratory pathogens we're monitoring. So along the x-axis, you have time, and then on the y, you have each of the different pathogens. They each have their own scale. So at the top, we have SARS-CoV-2, then influenza A, influenza B, RSV, human metapneumovirus, and EVD 68. So as you can see where we are now, which is all the way towards the right compared to about a year ago. So last year, when we were in respiratory virus season, influenza A peaked at the end of December, and we may have seen the peak early January this year. So you can kind of compare last year to this year. Influenza B peaked at the end of February last year, and we are not sure if we've peaked yet. We're only starting to see this steadily increase in concentrations across our network. RSV last year peaked in December of 2023. And now we saw high concentrations at the beginning of 2025. I almost forgot what year it is, 2025. So we're going to continue to keep an eye on that. Human metapneumovirus last respiratory virus season peaked in April. And as you can see, we're about, we're still slowly increasing. We don't know if we're going to go down or consistently go up as we head into the spring. And then lastly, we have EVD 68. Last year we had mostly non-detects, and then this year we saw a big increase across the whole WastewaterSCAN network in the end of summer and beginning of fall. Next slide. So here's a quick overview of SARS-CoV-2. As I mentioned, it is in the medium category due to median concentrations and no trends. Concentrations are coming down since the beginning of 2025, although we've started to see some more higher concentrations out of the Northeast, which is that green color. These are the aggregates by region. And across the board, the median concentration is down about 7% compared to 1 month ago. Next slide. So here's the current map. You can see this when you go on to the website and you click on the SARS-CoV-2 button on the left side of the navigation bar. So most sites are either in the medium and low category currently. Next slide. So influenza B, we just hit seasonal onset, and so we are in the high category due to high concentrations, but no trend over the last 21 days. We've seen a steady increase over the last, since the beginning of the year. And if you just compare the national aggregate, which is on the left, to the CDC positivity rates, you can see this steady increase, and they mirror each other very nicely. Next slide. And here is the current wastewater category map. And there's a split currently. We have 71 sites that are in the high category, 66 that are in low. And currently we do not have recent data from about 10 sites, so we cannot calculate categories for those sites. Next slide. And I wanted to go over human metapneumovirus briefly because even though we're not in seasonal onset, we're starting to see a slow increase across the board, across the WastewaterSCAN network. So we've had 65% of samples have tested positive for human metapneumovirus in the last 21 days. And the median concentration is currently up 30% from 1 month ago. And that is all we have for the category overview. And we will send these slides out afterwards. And we always recommend that you refer to the data.wastewaterscan dashboard to stay up to date on where we're at across the network. And so if anybody has any questions about the website, or if you want to get in touch with all of us, this email goes to myself, Allie, Stephen, and Marlene. And I think that's it. So I think we're going to stop the recording and we can kind of have some more questions.